Okay, when and if possible, can you go on a tangent and explain lazy loading? It's almost like Sean knows that I like to go on tangents here. Uh, I love the implication of that. It's like, hey, if you're looking for a tangent to run off on today, do I have a suggestion for you? It would be great if you went on a tangent talking about lazy loading. Do you, so I will also ask, by lazy loading, do you mean actually doing the, like, um, you know, lazy loading, or do you just mean generally, like, capital L the type lazy, or do you mean just lazy loading in general? You mean the lazy of T. Okay, that's what I was wondering. I'm like, which tangent do you actually want me to go on? Because lazy loading itself is a concept that we could go on a tangent about. But yes, there's also the types. Yes. Uh, yeah, so the type is just like an implementation that allows for easy lazy loading. But lazy loading itself is just a concept that you can just do. It's just, I'm not going to load this until later, until the lazy loading as a concept is essentially, I'm not actually going to do the work to load this until you ask me for it. So in that sense, an IEnumerable, for example, that is not containing a collection itself, that kind of an IEnumerable is actually a lazy loaded collection. You can kind of think of it that way, because it doesn't actually. It is entirely possible to write a lazy version of an IEnumerable, with the idea being that it does not actually calculate what the next value is until you ask for it, because it doesn't need to. If the underlying data in an IEnumerable is a collection, there's no calculation, you just step to the next entity. But an IEnumerable, since really all you're doing is asking for the next value, they can actually be lazy loaded and not calculated until that moment. So the neat thing, so that's actually what makes IEnumerables so cool. Yeah, you'll get me on a quick tangent. Here you go. Let's do a quick tangent. All right, everybody, we're going to do a quick tangent fun. We'll make this example. Here's what I'm talking about. In order to do this example, we'll do a quick tangent on we'll do an XUnit test in order to show it. Let's call it my example. There we go. Step 1, run the test to make sure everything's all wired together. Strap in, it's tangent time, gents! And everyone really, infinite IEnumerables. Yes, exactly. As Wheatlaw mentions, which we're going to do because it's going to be fun, an IEnumerable can be infinite. So be careful. All right, everyone, let's go. Let's do this. So, first off, funny things. We're going to go on a quick IEnumerable tangent because it's fun. IEnumerable, let's do an IEnumerable of ints. We'll call it numbers. Numbers equals a new list, and we'll just put in 1, 2, 3, 4, 5. Great set of numbers I did right there. So let's go ahead and do... Oh, is a console log going to show, or do I need to debug print this? We'll try debug printing. We'll for each over the numbers for now, because it'll be funny. And we'll do a debug print of, let's say, the number is number. Okay. Let's run this and see what we get as output. I'm not 100%. Not 100%. We need a tangent cam. Yes. Oh, and I do want to say, Nokta Brizo and Papa, welcome. Thanks for those follows. Much appreciated. Welcome to the stream. Hopefully you enjoy the crazy tangent we're about to go on. Okay, so debug print did not show. Did it come out in the debug? No, I don't see it there. Okay. So we don't see it there. All right, we'll try a console log, a console write line then. I thought that was going to show up, but why does it not want to do that? Oh, should use iTest output helper. Can you fix to that? Okay. I'm on board. Yeah, I'm on board. Thanks, thanks, Resharper. Appreciate it. Or whomever that was that told me that. Yeah, I know they don't like console output. That's why I tried the debug print, and I thought it was going to send it out to the debugger, but it didn't want to, and so I was like, why don't you... But yeah, that totally works. iTest output helper. There we go. Okay, so there you can see the number is 1, 2, 3, 4, 5. Excellent. Siska, welcome. Thanks for that follow. Much appreciated. Yeah, that'll be a longer one, Root Guy. Unit. It would mess everything up if you had multiple tests running at the same time. Yeah, that's true, Wheatlaw. That is true. Okay. Yeah, I assume then because it gets a type passed in like this, that what that would mean is that it can keep track, like it's probably giving us one of these for each instance, and it's probably then got the information about what type, which test it was associated with, so that it can run the tests all in any order or in any way it likes. So, okay. So that's our set of numbers. This is non-lazy loading. This is explicit, it's a collection. Everybody gets that one. Totally fine. Let's change this. So I want to make this a method. So we are going to make a method that's called getNumbers. Right? Now we have getNumbers. Let's look at how this code works. I'm going to put a breakpoint here, and I'm going to put a breakpoint here. For now, nothing weird is going to happen, I don't think. Assuming that this test actually runs, we'll find out. If it comes back inconclusive, then, okay, it's inconclusive. Of course it is. Okay, we'll show it this way then. I have another way to show it. So here's what we're going to do. We're going to change how this IEnumerable works. Prepare for brain to get fried. So for now, we're going to go simple. We're not going to do an infinite loop or anything like that. We're going to do up to... we'll go up to 5, and we'll just say yield return I plus 1. And we'll make this yield break, because I'm weird. Totally useless yield break. It does absolutely nothing, but I'm weird and I like it because I'm crazy. Okay, so when I do this, everything's going to look totally normal, and you're not going to understand that anything weird's going on. It's going to look totally normal. What is it? Well, true. Oh, geez. Yeah, see, Wheatlaw wanted me to go to a while true right away. I don't think I'm ready to do that one, because I want to be able to illustrate the example first. Okay, so everything looks totally normal, right? This looks like the same thing we had before. See, it's listing the numbers 1 through 5. This is totally normal. What are you talking about, Brendan? Nothing happened. No, totally okay. There's nothing weird going on. What could possibly make you think that something weird was going on? Almost like creating let's say I is, let's see, since I is something, it grammatically sounds so weird to a native English speaker, I'm not sure I can write that, so I'm gonna say the value of I is. I just can't write I is. It doesn't work. Sorry. Okay, so we're gonna do that, and then we're gonna run this code again, and let's see. Yes, I am. Yes. Let's have a look at the output. Huh. That's weird. So now hopefully everybody has realized the craziness that's going on right here, because I want you to take a look at this. This is the big reveal right here. So the first thing that happens, if we look at this output, let me bring it up so we can see them both at the same time. So we can see the for loops, we can see this data. So we go into this for loop, right? And we want to grab the first item of the numbers collection. And what do? It goes in here, it runs this for loop, And it gets here and it says the value of I is 0. And then we print out this number. And then somehow we're back inside of get numbers to get the next item. And then we print it. You would think, if you're looking at this code normally, that what would happen is we would see the value of I is 0, the value of I is 1, 2, 3, and 4, and you'd see all of these together. And then once you had the collection stored in this variable, you would see the number is 1, 2, 3, 4, 5. But that is not what is happening, because it is actually sending us back into that code. Here, I'll show you in with a debugger. We'll get it to attach in this, because it will run here. We'll debug this real fast. Also, hi Surly Dev, welcome, and Wheatlaw, welcome. I'm not sure I said welcome. You were talking already. Yeah. So craziness of IEnumerables. I think people will find it cool. Okay, so if we watch, numbers right now hasn't been created. There's nothing in this set. And wait a minute. Somehow I tried to step in. I have not been in this code yet. I'm here on line 23, and I have not yet executed the code inside of this method, despite it getting called right there. It has not been, we've not gotten in there yet. TBD Gamer, welcome. Okay, so now we're going to try to grab the first item out of it. So we said in, wait a minute. Now we just came from this in keyword, the in keyword, into a method. And then you step through and you're like, okay, now I'm in the for loop, I is 0. Okay. It prints out that message to say the value of I is 0. And now watch. We return back from here we have not yet completed our for loop, assign that value to number, so number now has a value of 1, print it out, and then come back up here, and then from in, I go back into the method, iterate back into the for loop, and then I come back out again, and it's actually going to do this with stepping between my two for loops. Every time we get to the in, we go back to the IEnumerable to get the next one. Isn't that crazy? So if you actually watch this, like, it really is like into the method, back out of the method, into the method, back out of the method, into the method, to get each item as it goes through the IEnumerable. So that's what I mean when I say the IEnumerable is actually lazy loaded. So, okay, so let's talk about the code that Wheatlaw tried to have us start with. So I wanted to show this because you can sort of see it at the beginning. Wheatlaw is, so not exactly T-Lock. So what is actually going on here is, this is called an IEnumerable, in C#, and really all so usually we think of an IEnumerable as like a simple abstraction for a collection, but that is actually not what it is. All that IEnumerable defines is that whatever this object is has a getNext method to call. Now, what is happening behind the scenes, because I created this IEnumerable that is doing yield returns, essentially, and I don't want to get into the exact specifics because that gets too weird, so I'm sort of going to explain it in a way that's only slightly lying. Think of it this way. It's sort of, I'm pretty sure they're creating a type, and they're creating a special type for this, and it's got methods on it, and the idea is that the getNext is actually calling through back into this method each time. So that's how it's getting us to this code an extra time. Each way we go through is it's calling through to this and returning back, and it's maintaining the state. So when we do things like lambdas and other stuff like that in C#, they're often creating a state object. So there is actually an object that's getting created to encompass the state of what is going on And that's all getting created for you, and you don't think about it and you don't see it. But if you actually look at what's going on with some of these, that's what's happening. With some of the more advanced stuff that you can do in C Sharp, it's really creating objects for you that you never even thought you were creating, that need to exist in order to let happen what you're doing. That's one of the reasons why when we talk about, if you can tell the compiler, hey, I'm not going to change this, hey, I'm not going to do these things, when we talk about like the optimizations that the compiler and the runtime can do for you when it has the information, that's the type of stuff that it can sort of optimize away. Is like, if it knows it's not going to change something, then it can tweak how it's creating these extra objects and stuff. Because C Sharp's doing that, there's a lot of places where it can do some extra optimizing. I'm not entirely talking about stack versus heap, but there is some aspect to that because we are mostly on the stack here. But yes, that is a related concept. Okay, so let's real quick do the code that Wheatlaw was suggesting, just so we can point out the fun here. So I can make while true, which actually, now that I think about it, I should just do it as a for loop, because why not? So instead of I is less than 5, we'll just say true, which actually, I think I can just leave it empty. Okay. So this is an infinite loop, because there is no resolution, so instead of saying that, I can do true, but that's the default case anyway, so I can just remove it entirely. So this is now an infinite loop, and you go, wait, Brendan, you really want to create an infinite loop? And the answer is yes. Yes, I do. Because that's fun. Yes, we do. Infinite loops are the best. Okay, so, for example, I can now say, take 100. So I can grab the first 100 numbers, run this code, and don't do a take. Wheatlaw, let me start with a take, please. But yeah, that's the idea. Is I can do this sort of thing, and you'll look, and you'll see it went until it got to the number is 100, and you'll see I grabbed the first 100 numbers. And yes, if I did long, then it would go go further. I could absolutely change from int to long. That is valid. We could increase the amount of these that we can make. Okay, so does take require an int? Oh my god! Oh jeez, take requires an int. we can't do it. We can't do it. Yeah, I know. I can get rid of take. You just want me to smash my computer, huh? Take int.max value. There you go. We'll go to int max. We'll get like 2 billion something. But here's what'll happen, and it's going, and it is chugging along. Yeah, it is not gonna, it's gonna take forever. This is gonna be terrible, especially since it's trying to do like, I mean, it's not like doing console output, but it is doing some output. So I'm gonna kill that because it's just not gonna go. Yes, exactly. Yes, because this is not going to do it until it finishes, the way that the helper works. If I did this as a console app, which is really what I think Wheatlaw would really want to see, then that would totally have worked. Yeah, why not? We'll do a quick console app. We'll take a look because it's funny. Create a new project. Come on. A console C#, .NET Core. That is not where those go. Scratch folder. What is this? This is enumerable craziness. T-Lox, random prime number is worse. So yeah, I've done prime number stuff a lot of times. I'm a big fan of doing prime number stuff because it's really kind of a neat concept. It's fun. Oh, I'm sorry about the white. I have no idea why Visual Studio, while in dark theme, in creating a project, would go white ever. I apologize about that, everyone. That was bad. It's fine if you use a light theme or a dark theme. Either one's okay. What's not okay is switching back and forth. That's just going to hurt everyone's eyes. You can pick whichever one you like, but don't switch. Okay. So let's go ahead and grab the code from our other one, which is this. And we're just going to take this code real fast, hop over here. Now, instead of doing the stuff we were doing, we're going to grab console logs, or console write lines, I mean. So we're going to do console write lines on those. This is now static again. No. Static. Static. Just gotta load in the right place. There we go. See? We made an infinite loop. This is how long this is taking. See that? That's taking forever. It's hard to even tell what those numbers are. I think we're only in the tens of thousands. I don't even think we're in 100,000 yet. Look at that. Yeah. There, we just crossed into 100,000. That is going to take forever. But that is the neat thing. So if anyone missed that, what we're highlighting right here is the really cool way that IEnumerable works in C#, in that because it is not actually a collection, you can have it lazy load each value at runtime. So this is an infinite loop of this, essentially. You need a blank project, yeah. Oh, oh, Wheatlaw, you're funny. Code askew? I'm not sure how you pronounce that. Maybe I'm just taking a guess. But either way, hi, welcome, greetings. Is there a way to refactor for efficiency? 2 nested for each loop. So the code we're writing, this is not intended, like the code we just wrote. That is not the way you would do this efficiently if you wanted to. Devils live on. Welcome. I'm guessing. Welcome to the stream. Thanks for that follow. So yeah, the code here was not intended to be efficient in any way. I mean, that's why it's like this. This is more to demonstrate that you can load some things after the fact. So times when you might do this, if there are calculation-intensive creation of an object, you might not want to do it even creating the next element until you need to. This could be like reading through some data or, you know, whatever. You don't need to get it until you do the next one. Or this could also be the creation of each one needs to be based on the previous one, and that sort of thing could also. The Startup CTO, welcome, greetings, hello. Thank you for that follow, much appreciated. It is funny to recreate all the loops in Link. Oh yeah, absolutely. Yes. So which actually brings up a really good point. So everyone take a look at the process memory over here and notice the fact that it is not changing. And now, while I understand that an integer is not exactly a large value, if we were to change this, so I'm gonna go ahead and stop this even though it's been running for a while. If we were to do strings instead of longs, for example, so that they take up a little bit more space, let's go ahead and make these be like some kind of word or something. this will take memory space. And just to make sure that each one is different, we're going to go ahead and do that. So if you're thinking that numbers is a collection, then this should get crazy. Do well, oh, okay, so here it goes. So we're watching that run. Okay, so we're up to our 16 megabytes of space. Let's see how 17 megabytes of space. Let's see how much it grows. Okay, so do well while 4-step for each. The fact that strings are immutable means a lot of memory use. You'd think that, Code with Sean. You'd think that. But look at the graph, and this is what I wanted to show you. They can be, it's exactly what Wheatlall just said. They can be garbage collected. So here's the key to remember about IEnumerables. So if you've ever gotten warnings about like multiple enumerations of an enumerable, this is what it's talking about. An enumerable doesn't have to be a collection. And in a case like this, it makes a huge difference. Because if we were to enumerate this collection multiple times, we would have problems as a result of that. So each one of these that it has created is getting thrown away immediately. It is not keeping the previous records. I mean, look at how much this is. There's no way that that graph is static. I'm not saying it would be spiking without it, but we would have a ton more memory usage than what we're getting. Because, you know, like, again, it's not a small amount, but remember, we're making tens of thousands of these. So, like, we should see it going up a little bit, and it's really not. Not by any extent that we would actually measure, because it's just going to throw away each string each time. So yeah, exactly, T-Lox. There's not a leak in the memory here or anything like that. It is actually throwing it away as you'd expect. And I could make the strings bigger if you want me to show that, but I mean we're about to cross like the million line here without, you know, having even impacted this. Exactly, yes. You'll see it goes up and back down and up and back down, and it's ever so slight. It just goes up until the point where the garbage collection kicks in and says, hey, you left a whole bunch of strings lying around, let me clear those out for you. And that's actually what it's doing, is we're just going up and down and up and down and up and down. And but we're not like uncontrollably rising. So that's the cool thing, is it really is just creating this and moving on. In fact, I could make an IEnumerable that spits out the current time, for example. So when the code tells you not to enumerate a collection, not to enumerate an IEnumerable multiple times, that's why. Is you don't know what an IEnumerable, you as a developer, you can't know for certain if it's just an IEnumerable. If you know, obviously if you didn't write it and you don't know that it's an underlying collection, you don't know what it is. And so the compiler, like the compiling of the tools and everything like that, is warning you, because it's sometimes unsafe to call an IEnumerable multiple times, because they could have state that they're changing. They could be based on some information that you don't have control. Exactly, yes. What Wheatlall's mentioning, you don't know what heresy people will pass into your function. Since it's essentially, you should not be trusting that the other developer passed you what you think they passed you. Like, if that person passed you something like this, you should be careful. And actually, if the other developer passed you an infinite loop and didn't tell you about that, well, that's a little crazy. But yep. So that's just the neat thing that I wanted to show, is that there's lazy loading. It really doesn't create those items until it gets to it. Grizzly Guru, hey, glad you're enjoying the stream. Thank you very much. I always like the hype. Let's go ahead and kill this for now. Let's jump back over to our code where we were writing this stuff for realsies. We'll get rid of that little side tangent stuff that we did. Okay. Let's go ahead and jump back into this code. So where were we? We are working on our plugin. We still have the bug where it's creating duplicates. Oh, if you enumerate an enumerable multiple times, so did I? If you do this right here, so even without the take on there, this we'll set this back to 10. I is less than 10. Let's watch what happens. Here, I'll give you the quick run-through of it. Alright, it loaded it on the other screen. So the value of I is 0. The number is, this will take memory space 1. So every time it says the value of I is, that means it came in and recalculated I. And you'll notice that on the second enumeration, it did it again. So each enumeration went through that collection and did it again. So it's like, if there were work to calculate it, or if the numbers could change, then that would cause us some problems. So if this is just returning I plus 1, for example, and we change this from string to long again, that's fine. And this I should have just made var so that we could be changing types out from under ourselves here. So if you look, it does both twice. Whereas if this were turned into a list, for example, so right here, it knows that this IEnumerable, the compiler can tell that that IEnumerable is a list now. We'll do it once. So watch what happens. When I run it this way, this is the code everybody expected to begin with, instead of what the IEnumerable did. You'll see it evaluates each of the values once, and then it does the two loops once each. And what caused that is I told it, by saying toList, I said, hey, I want to take your enumerable, grab all your values, and store these in an actual collection. Whereas with this removed, it leaves it as an IEnumerable, which means it's just a get next item placeholder. And when we run it, you'll see that, again, they're interweaved, and we have the calls into the method twice for each number that it gets. Yeah, so for example, yeah, as Code with Sean says, if you were calling to a database or something like that, then you would be calling the database again and again and again and again and again to get the next values. Or maybe you're reading them out of a file or something like that. Yeah. And yes, so as Wheatlaw's mentioning, there are types that handle lazy scenarios like this where you want to last minute grab things. Yep. And some of them do nice pieces where they will put it into a list so that the second enumeration doesn't have to do that. And that's actually a much better form of lazy loading, because then you really are loading and not just, lazy getting the value. And since we didn't save them, they were just going away.